Hello, beautiful people, and welcome. In today's video, we are going to be reviewing both volume and surface area. Now, you do need to know these formulas. However, I do recommend writing these formulas down on one sheet so that way you have a cheat sheet, you have a reference sheet, and in any case, if you forget a formula or anything like that, you know exactly what to look for. And that would be this paper. If you are in my class, I'm going to go ahead and take a picture of this and post this so that way you have it in a picture format. All right, beautiful people, disclaimer time. We will be doing examples. So if I make a mistake, please let me know so that way I can learn from my mistakes. First thing first is volume. We started out the semester with volume, and there are technically three formulas. The prism and the cylinder formulas are the same. The pyramid and the cone formulas are the same. And then you have sphere. Now, when I say there's technically three formulas, the cylinder and the cone both have a base of a circle. So that way, when we do the area of the base, it will be pi r squared, area of the base, area of the base. Now, I need you to remember that capital B is the area of the base. H is the height of your 3D figure. May it be prism, cylinder, pyramid, cone, it's just your height. Now, you need to remember that the height needs to be perpendicular to the base. If the height is not perpendicular, if it does not meet at a right angle, then it is not your height and you need to find your height. After volume, we went through lateral area. Now, lateral area is the area without the area of the bases, okay? So it's basically the area without the bases included. Here we have, again, technically two formulas. Prism and cylinder formulas are the same. Pyramid and cone formulas are the same. Because a sphere has no base, there is no lateral area. Sphere, you're thinking like a basketball, baseball. It does not have an actual base. Now, for a prism, the lateral area, again, the area without the base, is the perimeter of the base times the height of your prism. Same thing here. Perimeter of the base times the height of your cylinder. Now, notice that I went ahead and changed it a little bit because what we know is the base of a cylinder is a circle. So I need to make sure that I have the perimeter of a circle. Now, a perimeter of a circle is the circumference. And so this here is the circumference of the circle times your height of your cylinder. Okay, pyramid and cone formulas again are the same. It is 1/2 times the perimeter of the base times the slant height. Now, here's your first change. Slant height is a lowercase cursive L, okay? Now, same thing like we did with cylinder, we have to do with cone, the perimeter of the base. The base is a circle, so what is the perimeter of a circle? It is the circumference. So I am replacing the perimeter of the cone with the circumference of the cone. Again, same thing. And then again, we have our slant height. Notice that P is the perimeter of the base. Lowercase cursive L is called slant height. Now, slant height of a cone looks something like this. Slant height of a pyramid looks something like this. I'm going to actually draw this out a little bit better. So if we have this triangle here, it would be down the center of that triangle on the pyramid, and it does meet at a right angle to the base. So sometimes they'll do that. This is not your height. This is your slant height. So slant height. Now again, for a pyramid, whenever you have something like this and they give you this measurement here, this is your edge, not your slant height, okay? So your edge is your edge and your slant height is from the vertex to the center of one of the sides of the bases. All right, sphere, once again, no lateral area. Now we move on to surface area. Now surface area combines lateral area because lateral area is just the area without the base. So surface area is the area without the base and then we add the base to it. So you're going to find a lot of the formulas are just going to tell you lateral area, lateral area, lateral area, plus however many bases you have. For example, a prism has a base on top and has a base on the bottom. A cylinder has a base on top, has a base on the bottom. A pyramid and a cone only have one base, and a sphere, again, doesn't have lateral area. So we have a new formula for the surface area of a sphere. Now I went ahead and I input the lateral area into the formulas of surface area, so it'd be a little bit easier for you guys. So surface area is equal to the perimeter of the base times the height of the prism plus 2 base areas. Again, this is base areas. Same thing for cylinder, except for lateral area, I went ahead and I already converted it to a circumference of the circle. Remember, here we are, cylinder, circumference of the circle times the height of the cylinder. And then again, we have 2 area of the bases. So here is my area of the base, which is a circle, which is pi r squared. And we have 2 of those. Now, pyramid and cone, same thing. 1/2 times the area of the, 1/2 times the perimeter of the base times the slant height plus 1 area of the base. Cone, same thing. I went ahead and I changed it because our base is a circle. So we have circumference times the slant height times 1 area of the base, and all of that is divided by 2. And your sphere formula is 4 times pi times r squared. Now, again, I recommend writing all of this out so that way you have it while we work on these examples. And well, let's go ahead and get started. All right, beautiful people, here's our first example. Let's start with step number 1. I'm actually going to divide this sheet of paper in half because I'm going to be dealing with surface area and volume on each example. We're going to be working with both. So I'm going to split this up. Let's start with volume. So for volume, I have 2 objects. I have a rectangular prism, and on top of it, I have a trapezoid. Okay, so I have 2 prisms. One's rectangular, one's with a trapezoid. Now, both of the prisms will have the same formula. Now, it doesn't matter what the base is because in the formula, we're saying area of the base. So whatever the base is, we find the area of it. All right, so the formula, I'm looking at my cheat sheet. If you don't have this memorized, make sure you have this in front of you. So rectangular prism volume, make sure you're looking at the correct formula, is the area of the base times the height of the prism. Same thing here, area of the base times the height of the prism. So now I have, what is the area? This is a rectangle, so I have length times width times height on this one. So what is this? It's 3 by 5 by 6. Let's see calculator time. All right, let's see here real quick. 3 by 5 by 6. It is 90. All right, now we have to do the same thing. Area of the base of a trapezoid. Okay, so we're taking the bases. So let me actually draw this out for you. This is what we have. Here we have a height of 2. We have this side of 2.5. We have this side right here, which is the same as here, 2.5. And what do we have? We have the top, which is 2. And we have the bottom of the trapezoid, which is 5. And area of the base is 1/2 times base 1 plus base 2 times the height of the trapezoid. Again, what is our objective right now is to find the base area. All right, base 1 and base 2, what that means is just the top and the bottom of your trapezoid. So we have base 1, base 2. Let's go ahead and find this. I'm doing this kind of off to the side because I know that in my surface area formula, I'm going to need to figure out the base. So we have 1/2. I have base 1 is 2, plus base 2 is 5, plus the height is 2. And I'm doing a happy dance because they gave me all the information and I don't actually have to work too hard to find it. So 5 plus 2, that is 7. 7 times 2, that is 14 divided by 2, that is still 7. Now you didn't have to do that. All you had to do is realize that you have a divided by 2 and times 2. Here's times 2. Here's divided by 2. And 5 plus 2 is 7. So base area is 7. All right, let's go ahead and plug this in. So base area is 7 times the height of your prism. Now, if this is new to you, make sure you're watching the volume videos because anytime you have a base that is complicated, what I mean by that is it's not a rectangular prism, any other base. Assume that you're taking that base and putting it on top. For example, here is a cylinder. The base is not a rectangle. So assume that this cylinder right here is being put this way here. So you're putting it onto the base. Same thing you're doing with this trapezoid. This trapezoid, it's laying this way, and then you're going to pick it up and you're putting the trapezoid onto its base. So if we put the trapezoid onto its base, this part right here, let me show you. Woo! Did you guys see that? I just threw a pencil. Or that was a pen. This part right here, this base is going to be on the floor, on the bottom, or on this table. And then this base right here is going to be on top. So because of that, our height of our trapezoidal prism is 6. So 7 times 6 is 42. So again, for volume, in my opinion, is a lot easier for composite figures because all you need to ask is, did we put anything together or did we remove it? So we actually put the trapezoidal prism on top of our rectangle prism. So that means I am going to add those two things together and call it good for volume. So 90 plus 42. 90 plus 42, I get volume total for the composite figure is 132 centimeters. What do we have? Volume is always cubed. In my opinion, volume is a lot easier than surface area, but here you have volume. Let's do the exact same thing now for surface area. I'm going to use a little bit more space. Again, we're doing the surface area for the exact same composite figure. What do we have? We have a rectangle prism and a trapezoidal. I'm just going to call it trap. Again, now we're writing out our surface area formulas, not our, what is it? Volume. We just did volume. Okay. Surface area formula for rectangular prism is perimeter of the base times the height of your prism plus 2 area of the base. Same thing for the trapezoid prism. Doesn't matter what the base is, the formula for a prism remains always the same. Perimeter of the base times the height of the prism plus 2 base areas. Okay, now I do want to mention these. These are going to be a little bit different than the examples we've done in the past because it's a little different. Okay, so let's start out with what do we have? I'm going to look back up here. If you have not already watched the surface area videos, go ahead and do that because I did try my best to show you with tangible things how surface area works. So surface area works, what can you touch? So what can you paint? If here's a little paintbrush, little sponge. So what can we paint? We can paint this section, we can paint this section, we can paint inside section. Let me see if I can draw this out really quick. We can paint this section, we can paint this section. I can pick this up and we can paint the bottom because I can pick it up, you know, I can move it. I can paint this area, this trapezoid. I can paint the other trapezoid. I can paint the top, the two sides. What I cannot paint is what's inside. So what is inside is this rectangle right here. I have this rectangle in my trapezoidal prism. And I have this rectangle in my, trying to find a different color here. There it is. In my rectangular prism. So I don't have those two. I don't have that, and I don't want to call it a base because it's not the base. For the trapezoidal prism, the base is a trapezoid. But I don't have that bottom, that side in a way of that trapezoidal prism, and I don't have that rectangle in my rectangular prism. So I'll show you a different way of doing it than the way that we've done before. Know what you have. So for example, I have a rectangular prism, I have a trapezoidal prism. Let's find the surface area of both, but that is not going to be your final answer because there are things that have been removed from that surface area. So perimeter of the base, rectangle. Let's back up a little bit or move this forward. I'm going to draw a small rectangle here. Let's assume that for the rectangular prism, it will make our life a little bit easier. Again, trying to find all these different colors is not working out. Here's my base for the rectangular prism. Okay, here's my base for the rectangular prism. So I have a base here and I have a base here for my rectangular prism. Now notice that I can only reach one. I can pick this up and I can paint the bottom. However, I can't paint what's inside. So instead of having two areas of the base, I have only one, just one, because I have a rectangular prism minus one base. This one here for the rectangular prism doesn't exist. All right, we want the perimeter. Perimeter of this is 5 by 6. So I have 5 here, I have 6 here. 6 times 2 is 12. 5 times 2 is 10, so I have 12 plus 10. 12 plus 10, it should be 22. So I have surface, so the perimeter is 22. I'm going to need the area of the base. 6 times 5 is 30. So I'm going to put that information here. So surface area is equal to the perimeter, which is 22. Then I have times the height. So if I made this my, excuse me, you guys, if I made this my base, that means my height is now 3. Plus 1 area of the base we said is 30. So 22 times 3 plus 30 ends up being 96. Again, what are we working with? We're working with centimeters. And so again, we minus that one base, so that's fine. Now for the trapezoid prism has everything except that one rectangle. Again, here's the trapezoidal prism, and on the, here's your trapezoid right here. Obviously, this is a circle, but I'm just using this as an example. Let's say here's your trapezoid, top and bottom trapezoid. So this side here would be this rectangle. Now, this rectangle has an area. It has an area that we cannot reach. So what is that area of that rectangle on the trapezoidal prism? And that, once again, is exactly the same as the rectangular base. So I have my trapezoid prism. However, I have a rectangle. So I have a rectangle area missing. So we're going to subtract one rectangular area. So what is the perimeter of my trapezoid? Let's go ahead and back up here. We know what the base area, we said base area was 7. Now we need the perimeter. Perimeter is just all of the outside measures combined. So I have 2.5 plus 2 plus 5 plus 2.5. 2.5 times 2 is 5. 5 plus 2 plus 5 is 7. That's weird how that worked out. Let's try that again. 2.5 plus 2 plus 5 plus 2.5. Oh, that is 12. So I'm very happy I checked that. And just because I made a mistake originally, I'm going to count one last time. 2.5 plus 2 plus 5 plus 2.5 is in fact 12. That is my perimeter. So now I have my base area and I have my perimeter. Okay, perimeter we said was 12. The height of the prism, again, height of the prism is taking that trapezoid. Let's assume this is a trapezoid, putting it on the bottom, and then this is your height. So the height is still 6 plus 2 area of the bases. Now, don't subtract the area of the base because that's not what's missing. We can get to both trapezoids, top and bottom. What we can't get to is this rectangle that's on the inside. So we have 2 times the area of the base, which was 7. Let's calculate that. 12 times 6 is 72, plus 2 times 7 is 14, so we have 86. Now again, that's not what we have for our surface area. We have this surface area minus 1 rectangular area, and that rectangular area we already said was 30. So 86 minus 30 is 56. Now that we actually have both, this is what we're trying to find, surface area. So surface area is squared. Now we combine it. We can reach the outside of the trapezoidal prism. We can reach the outside and the underneath part of the rectangular prism. So we're going to combine that surface area. I have 96 plus 56. And I have 152 centimeters squared as my surface area for the composite figure. All right, guys, let's go ahead and move on. Again, if something didn't make sense, reach out to me, pause the video, rewatch it, and then hopefully you were able to do this without my help. Let's try another example. Here's another example. Please make sure you're pausing the video, trying this on your own, because this is a review video. You should be able to do these on your own, okay? All right, let's go ahead and see what this one's going to be. Again, let's start with volume. In my opinion, volume is easier, so I like to do it first. Two things that we have the cylinder base, and we have this cone. I already know from doing the previous example that I'm going to need my base area of my cylinder, and I'm going to need my base area of my cone. Okay, so I'm going to need that. What's really cool is that the base is the same for both, because the base of a cylinder is a circle, the base of this cone is a circle, and looking at this image, it looks like they are exactly the same. So we're going to find the base area of one circle. So base area, what do we have? We have radius of 5. So base area is pi r squared. So I have pi times 5 squared, and that is 25 pi for my base area. Now I also will need to find the perimeter. The perimeter is the circumference. So it's 2 pi r 2 pi 5, which is equal to 10 pi. And I did that in advance because from the previous example, I know I'm going to need the perimeter and I'm going to need the base area. All right, let's write out our formulas for volume. Volume is, for a cylinder, same thing it was for the prism. It's the area of the base times the height of your cylinder, area of the base. Now for cone, it's different. Cone is the same as a pyramid. So for the volume of a cone, it is 1/3 times the area of the base times the height of your cone. Plug and chug, we already know what the base area is. We solved that already, which is 25 pi. Height of your cylinder is 2 centimeters. 2 times 25 is 50, so I have 50 pi as my volume for my cylinder. Now let's work for the cone. Area of the base, again, same thing as 25 pi because they share this circle here. And then we have the height of your cone. Height of your cone, again, has to be perpendicular to the base. If it is not perpendicular to the base, you don't have a height. You have something else. So here we have a height of 13. Now I was able to do that one in my head. This one, unfortunately, I cannot. I don't know what 25 times 13 is, so I'm going to use my calculator. 25 times 13 is 325 divided by 3, and I get a decimal. So let me go ahead. I actually get a fraction. My calculator does exact answers. So I get 325 divided by 3, which I'm going to start rounding. And I'm also, so I get 108.33 pi. And I'm going to multiply both of these out since it's already in a decimal format. So I'm going to have that times pi. And it gives me an approximated answer of 340.34 for my volume for the cone. And then for volume of the cylinder, it is 50 times pi, which gives me an approximated answer of 157.08. Again, volume, all you have to do is ask yourself, did we put things together? Did we remove anything? Nothing was drilled out. We just put that cone on top of your cylinder. So we are just going to add these things together. So I have 157.08 plus my original 340. And that gives me a volume of 497.4 centimeters. Yes, centimeters. What are you trying to find? Volume. Volume is always cubed. And that's it for the volume. Now again, surface area is going to be a little bit more difficult because we need to figure out what we have, what we don't have. So now we're going to do surface area. So again, we have our cylinder and we have our cone. Let's go ahead and write out our formulas for both. Surface area for a cylinder is the same as a prism. It is your lateral area plus 2 bases. So lateral area plus 2 area of the bases. However, lateral area is the perimeter of the base times the height of your cylinder. And in this case, we know the perimeter is our circumference. And we already know what that is because we did it in the beginning. We worked ahead, which is 10 pi. The height of the cylinder is, what is the height? Oh, excuse me. The height of the cylinder is, where's my cylinder? Oh, 2. I was looking at the cone and saying, that's not right. Now, before I continue, there's one thing that we didn't do is we didn't identify what we had. Okay, what we had and what we didn't have. What we had was this cylinder, okay? So here's the bottom of the cylinder. Here's the top of the cylinder. Because we have a cone on top of our cylinder, here's an example. It won't look the same, but here's the cone, here's the cylinder. Because we have a cone on top of the cylinder like this, one of the bases is going to be missing, okay? So if I take my now famous piece of candy, throw it in our cylinder, I'm able to go from the cylinder to the cone and from the cone to the cylinder. So what we have is we have the lateral area and one base for the cylinder. And what do we have for the cone? We just have the lateral area because we have no base. So from our surface area of the cylinder, we need to remove one base. So we have a cylinder minus one base. So instead of two bases, I'm going to say just one base. And we know what the area of the base is because, again, we already did that. That is 25 pi. Trusty calculator time. 10 times 2 is 20. 20 plus 25 is 45, and I get 45 pi for my surface area of the cylinder. Now we do exactly the same thing for the cone. Again, remember, cone has the same surface area formula as a pyramid. So surface area of a cone is your lateral area plus the area of the base. But here's the thing, you guys, before we even move on, we know we are taking away one base or the base of your cone because we need the candy to go from the top of your cone all the way down and be able to go between the two figures. All right, so we don't need this area of the base no more. We're going to remove it. So just what we have is lateral area of the cone. So what is the lateral area of the cone? Lateral area of the cone is 1/2 times the perimeter of the base times your slant height. Okay, so what is the perimeter of the base? We already know that that is the circumference, which is 2 pi r times your slant height, but we already know what the perimeter or the circumference of your base is. We already did that earlier on, and that was perimeter was 10. I'm going to do 10. It was 10 pi, excuse me. And now we have our slant height. Now, slant height for a cone has to be on its side. So it's either this right here or this because both of them are the same. But we want one of them. Unfortunately, that information is not provided to us, so we're going to be doing a thinking bubble and solving for our slant height. Here's some area on my paper. So slant height, this is what we have. I know I have a radius of 5, and I know that my height is 13. So we're going to use the Pythagorean theorem. So I have 13 squared plus 5 squared is equal to my slant height squared. 13 squared is equal to 169. 5 squared is 25. So 169 plus 25 is 194. We're going to take the square root of that. And it gives me an approximated 13.93. Again, we can't have a negative measure, so we're only taking the positive version of that. So now that we have our slant height, 13.93, bringing it down here, multiplying that by 10, dividing that by 2, and I get about 69.64 pi. And again, because we already have a decimal, we're going to approximate and round. So I have 45 pi, and I have 69.64 pi. Together, that gives me 360.15-ish centimeters for my surface area. What are we trying to find? Surface area. Surface area is always squared. Now, here's the thing, you guys. I don't know if I ever mentioned this. For surface area, once you remove what you can't reach, you're always going to add at the end. Okay, if you're using my method, if you're using a different method, that might not be true. But if you're using my method and already removing what you cannot reach, then for the surface area, these two, you're always going to add. All right, beautiful people, that is it. If you have any questions, please reach out. Surface area is very different, very difficult. I am always here to help you. If I made a mistake, I apologize. Please let me know where the mistake occurs. As always, thank you so much for watching my videos, and I will see you in the next one.